Hello everybody, I'm Callum at Repair Wins, as you may know, and I have a fairly quick project to put together today. So I've got this PCB here. It's from my old de-soldering station, the ZD-915. I've recently upgraded that station and replaced this board. So I removed the resistors from it and I was going to scrap it. But I thought, why don't I instead dig through my stash, and I can get these. I can solder them to this PCB. I can solder some wire, you can bridge these two together, bridge these together, and then I can solder a wire on, and I can use it for discharging capacitors. Because if you're working on a microwave or a mains power supply or something else that may be storing a lot of power, you don't just want to put your multimeter probes on, because you could very well blow the meter up. And obviously you don't just want to put your fingers to it and hope for the best, because you could blow yourself up. So the smartest thing to do is to use a resistive load, like we're going to build here, to then discharge the capacitor, and that way you connect it for a few moments. The theory is it's all discharged, and then you can obviously put your multimeter probes on, you can start diagnosing. What I'm going to do though is just solder these things one at a time. They should hold themselves in place, but I'm not going to be impatient. I've got all evening. My only issue is that the tip on this iron is really burnt out. I desperately need to replace it, and I do have a pine seal, but it's annoying to have the pine seal plugged in and this, because it's a soldering iron hot air station combo that I have. So in the meantime I just use this and I have to keep cleaning it off, and no doubt I'll end up repairing this, even though it makes a lot more sense to just start using the pine seal. But you know, either way, that's done. So I can now get the second resistor and just put it in, and we can do the third and the fourth. But because I'm a bit picky, I'm going to make sure that they're all facing the same way. So that one's in. I'll just flip it over, hold it down. So like I say, 365 degrees Celsius, and you can see it's already, you know, it's already burning up. Alright, so I do hold it for a moment, make sure the solder flows. Do the same here. Now this PCB was from 2013, yet I bought the tool in 2021, so they clearly just sit in a warehouse for God knows how long. Right, let's get the other two done. There we are, that's the four of them soldered up. What I need to do now is cut this trace here, because if I don't cut it, then this resistor is, for whatever reason, shorted to the output of this one. I don't quite know why that's been designed like that. All I do know is that we don't need it to be that way, so I'm just going to take this flathead screwdriver, and I'm not going to be gentle, I'm going to scrape pretty hard until I'm certain I've cut through the trace. And at the end we can use a multimeter to verify. Right, I'm certain I've cut through enough there. So I'm just going to take a toothbrush with some alcohol on it and clean that off. Might as well clean the whole PCB while I'm at it, just in case there's any solder balls or flux or whatever left on there. So that groove has been etched. We'll just confirm with the multimeter, but those 2 points shouldn't be connected anymore. If you follow any channels like mine, then no doubt you'll have seen this 1,000 times. But I'm going to put the multimeter into continuity mode. That's the mode that beeps. It shouldn't beep because they're no longer connected, because I've obviously cut the trace. And to be honest, I can't even get it to beep at all, even when I'm trying, so that's good. So this is definitely cut. In order to connect the all four of these together and all four of these together, two of them are already connected by, you know, the pads on each side. So the theory is I only need to connect here to there, and then the rest of it's done by the pad. But the reality is I would like to connect all four, you know, the wire to all 4 points, just so we're not putting any extra strain on the PCB or whatever. So I will open up the wire cutters, remove all of this. There we go. I can now pull the rest off by hand. There we go, wonderful. Twist it all up. Nice, high quality aluminium wire. And then I can just solder it on. So I think I'll solder this point here first, and then I can bend the rest of them into position. Brilliant. I've stood this up so you can at least pretend you can see what I'm doing. I've switched the iron back on. Right, we're just waiting for the iron to heat up. I'm going to tin the end, press it into place, solder it on, and then go along. There we go, the end's tinned and I've left a big blob on the end of the iron. Yeah, I think I'll solder it just directly onto the pins. So now that that's in position, I might actually do the fourth one. That's exactly what I'm going to do. I'm going to put some solder on here, try and flow it through to the bottom, because the heat isn't going to wick all the way through the wire and desolder there. So once I've done the start and the end, I can basically do the 2 points in the middle. Wonderful. This isn't the best solder work in the world, but I'm going to add some flux afterwards and just flow it down nicely. There we go. Right, that's the third point done, and we can just do the fourth one. I'll do the same thing on the other side, but I'm not going to make you watch me do the same work twice. That would be a bit silly. You've already watched me do the same work 4 times. But anyway, you can see the 4 solder joints are quality. They're obviously not going to go anywhere. And as a bonus, I've realised I can fish the piece of wire through here and then run it off to whatever device I want. And when I've soldered these 4 points up, I'll be able to do exactly the same thing, fish the wire through the middle and run it off to where I want. As promised, I've soldered up the second side. For this job, I've decided to use some mains cable. The reason why I've used mains cable is that it's obviously going to be carrying mains voltage, but also because it's double insulated. So you can see we have this insulation on the wire, but then covering it is this black insulation here. So pretty much the 2 layers provide extra protection. Right, so good news, I've managed to snake the brown one under. I'll just bend this like this so it's not in the way. And then the blue one, let's see about getting that under there. So I'll just give myself a bit more leeway. Right, see about this blue wire. Easy enough. I'll grab this one. These 2 are now both about in the centre. If I just pull, sort of fold you over on yourself once, fold you over on yourself once, and then try and fold it back in the direction of the wire. There we go. I can now cut the excess, and I'll do the same here. Fold that, and then back in the direction of the wire. If I now solder these up, I'll be able to cut the excess off. So that is more than enough solder, because I always put a bit more on than most people do. But you can see that it's flowed through nicely, and that these 2 pins are stuck down very well now. As promised, I've just cut the tails off, so now they're nice and flat to the PCB. This wire is obviously rather long, but that's really not a problem. If I decide it's too long, I can either just coil it up twice here, for example, and then throw a zip tie around it, and just reduce the length as I please, or worst case, I can just snip it off. But what you saw me do in the last clip was just stripping back the insulation, putting some solder on here, and then soldering these up so I can use them a bit more like pins. The perfect way to do this would be to use some multimeter probes or something like that, but I'm not about to go and spend money on multimeter probes just to snip the end off of them, to solder them onto this thing. What I've done is I've set my bench power supply up, so I set it to 32 volts at 3.5 amps, something like that. Now, in a perfect world, I'd be able to set the thing to 350 volts at maybe half an amp or something, to emulate how a capacitor actually works. But number one, I don't have a way of generating 350 volts, and number two, I don't really want it here on the desk next to my hands, ready to electrocute me. But if I turn the power supply on, poke the probes for a minute, so you can see it's only drawing 0.02 amps, which was a bit surprising to me. But my thermal camera demonstrates that it is heating up, so you can see it's sort of 28.7, and this room definitely is not 28 degrees, I promise you that. So 29.2, and then if I hold it there for a bit longer, 29.6. Yeah, those resistors are slightly warm to the touch. So this is a working concept. It's something you can put together yourself in 20 minutes if you have the PCB spare. In the end, I decided that I'd print a very, very simple little holder for this mechanism. So you can see that, if I use this zip tie as a pointer, that we've got these 4 little ledges here. So the board is going to go into place, it'll click, and then it'll sit on those ledges. I don't think I'm going to need to, because it should be a tight fit, but I might also just put 4 drops of super glue, 1 in each corner, and then that way the board can be pressed down and it's never going to go anywhere. And I've got this post sticking out, hence why I have 2 zip ties. The idea is I'm just going to put the board in here and then zip tie this cable to the post, and that way we're not tugging on, you know, this joint every time. I can fit the board into place, and fingers crossed it fits, because I measured it and then I put a 0.3mm tolerance in. Ooh, look at that. Yeah, I'm not going to need to glue this, no way. I keep pressing. I'll just use this screwdriver to help me get it down into the corners. God, you can see me straining there. But that is now sat nice and flat the entire way around. If I just now get the zip tie, and I can now bring this around, and that way, look, I can crank this here. So I won't crank it down fully, I'll just leave it on there loosely, and I'll do the same for the other zip tie. And then these two zip ties are going to act as the strain relief. So I can now clamp that fairly tightly, clamp that fairly tightly. Now all the strain's going into this post, look, so this PCB is now completely protected from any strain. And the idea is this will literally just sit on the desk next to the item I'm working on. And then I've got this nice long lead that I can put all the way down, poke onto the capacitor, and then discharge it without me physically having to go anywhere near it. There we go then, that concludes the video. Turns out I didn't even need to use my super glue, which is good, because super glue, it's not expensive, but you don't get much of it for the price that you pay. But all I've done is I've just neatly sort of wrapped this up, and the occasional time that I do need to use this, I'll be able to unwrap it, poke the cap, and then discharge it. So that is a nice quick project, really easy to do. I'm going to put this 3D model on Printables, there'll be a link in the description. If you've got the same PCB that you took out of the same de-soldering station, then hopefully you'll be able to use it and you'll find it useful. And then of course your wire will just lie flat like mine will, you can zip tie it on, and that'll be that. But that's it for this video. I hope you found the little project useful. If you did find the project useful, feel free to leave me a like. If you want to see similar projects in the future, then feel free to hit the subscribe button. But that's all for now, so take care, and I'll catch you in the next one. Goodbye.